only mode.
Welcome to the webinar today, everyone. Sorry for the slight delay in getting started. My name is Terry Ersman. I'm with GridGain, and I will be your host for today's webinar. Before we get started here, a couple of housekeeping items. If you can hear me, would you please raise your hand in the GoToWebinar control panel? Great, I see hands going up. Thanks, everyone. We will, as we go through the webinar, if you will enter your questions in the chat window, we'll answer as many of those as we have time at the end. And we will be recording today's webinar. We'll send a link to the recording as well as a copy of today's slides later on today. With that, I will introduce our speakers. So we have Rachel Podresky, who is our Director of Solutions Architecture here at GridGain Systems, and she's going to talk about using our multi-data center replication to build bulletproof applications. Rachel?
Thank you very much, Terry. Good morning, good afternoon, and good evening to all of you, wherever you are. As Terry mentioned, I am Rachel Podresky. I am the Director of Solutions Architecture here at GridGain Systems. GridGain is the corporate sponsor behind the Apache Ignite project. So I get the absolute joy of talking to all of my customers around the world about how they are using GridGain Enterprise and Apache Ignite in production to help solve their in-memory data pipeline needs. So I'm very excited to be here today, and I'm very happy that you all have joined me. So first off, I am going to tell you what I'm going to tell you. So the who, what, when, where's, why, and how's of this particular webinar today. We are going to start with what is Apache Ignite and GridGain. I'm going to go through this fairly quickly because we've got a little bit more meat on the matter, but I do want to start somewhere and give everybody who may not be familiar with Apache Ignite and GridGain Enterprise and how those different products work and fit together. We're going to talk about who out there will need multi-data center replication, why using multi-data center replication, sorry about that, is essential to any modern data-intensive application, where you can employ it, how it works, and when should you use it. So that's what we're going to be going through today. As Terry mentioned, please put any questions in the chat window. We started a little late today, so if we don't get a chance to do the questions at the end of the webinar, I will definitely address all of those via email, or you can hit me up on Twitter. I'm happy to help in any way that I can. So first off, a word from our sponsor, Apache Ignite. So Apache Ignite is an open source project. It is an in-memory data platform that will allow your application to move into the 21st century. So there's a number of features that are built into Apache Ignite that I'd like to talk about so you have an understanding of where you can use it and why. First off, traditional applications speak directly to the database. Where Apache Ignite and GridGain Enterprise fit is right in between your application and your system of record. The first feature to keep in mind is in-memory. GridGain Enterprise is an in-memory platform. It is memory first. It is designed and optimized to use all the memory that you have on your machines. This includes a key value store, an in-memory file system, and also in-memory indexes. So as we are moving towards better RAM, non-volatile RAMs, more and cheaper hardware available, Apache Ignite and GridGain Enterprise are the perfect solution for your next generation platforms or accelerating your existing ones. So if you want to take an existing platform, you do not want to reconfigure it, you can slide GridGain Enterprise in between your existing application and your system of record, or for new applications that you want to be designed for the new hardwares that are out there. This is a great solution for you. It's always available. So as it is a distributed system, it has availability guarantees built in. And that's what a lot of this webinar is going to be about. So I'm not going to go into a lot of detail here. But keep in mind that you can set up replication, you can set up backups. There's always going to be a copy of your data living somewhere. So if you do have an outage, you will not have any downtime. It is a scalable solution. So much like every other distributed system out there, as you add more hardware to your systems, as you add more servers, you get to horizontally scale your system. It is simple as saying, hey, this is a new box, add it to the cluster. Behind the scenes, the data will shuffle around and it will become available to you. But what's unique about Apache Ignite and GridGain Enterprise is that it's also vertically scalable. So you can, our engineers have managed to move all of our objects off heap. And so what that means to you is that you can use all the memory that is available on your systems for data processing. You do not have to rely on just your Java heap as your only place that you can store data. So there's a lot of NoSQL systems out there that are distributed, that are always available, that have a memory component, but none of them have the ability to use plain old SQL 99. And this is essential as you move, as your application becomes more popular, as people want to get to the data that's in it. I see this over and over and over again, that starting off, hey, yeah, we don't necessarily need SQL, but 6 months down the road, you're going to have other teams and other groups that are going to need that access. So out of the box, Apache Ignite and GridGain Enterprise are 100% SQL 99 compliant. So you can use joins, you can use group bys, you can use aggregates, all those things that you miss out with your NoSQL systems out there, you have in this system. You also have the ability to have full consistency. So full ACID consistency, not always eventual consistency or weak consistency. You have the ability for ACID consistency. There's also no rip and replace. So some of the NoSQL systems out there are not designed well for an existing application. You really need to rewrite it because of the data modeling needs and the way that the data is set up in the system. With Apache Ignite and GridGain Enterprise, as I mentioned before, it will slide between your application and your system of records, so you don't need to completely change your application's underlying data store. You can even use it as a stepping stone. I have a number of clients that will implement GridGain Enterprise, and then over time slowly move away from the from using their current database. Maybe it's a relational database or NoSQL database. I also like to mention here that we now have a new feature of our own persistence layer. So you have now the option of using a relational database to persist your data, a NoSQL database to persist your data, Hadoop to persist your data, or Ignite and GridGain Enterprise comes with its own persistence layer now as well. So it can replace any in-memory database that you might have. We also have a very tight integration with Spark. Spark is a distributed computation system, but it doesn't have its own data storage layer. What it does is it takes data from the system that it's looking to do analysis on, it moves that into what's called an RDD, and then once that session is done with that RDD, the data goes away. What GridGain Enterprise can provide you is a place to pin those RDDs into memory, so it can be reused by various clients in various sessions. So we have a number of customers who are really happy with this, and it actually speeds up their entire data pipeline. So how does Apache Ignite and GridGain work together? How are the different versions? So first off, Apache Ignite is the open source project. GridGain Professional is the Apache Ignite project, but hardened and gone through a more rigorous QA, and also available for support and services from GridGain. The features that are in GridGain Professional include a data grid, which could be used for caching, a compute grid, which could be used for distributed compute. So those are the two main features of the product. And then a number of APIs that are built on top of those two to enable OLTP caching, OLAP caching, streaming, messaging, and microservices architectures backbones. All of those features are well documented in other webinars, some by me, some by some of my fabulous colleagues. So if you're interested in learning more about streaming or microservices or OLAP, please take a look at some of the other webinars that are out there. The last one I call GAS, or Grid as a Service, and this is really where we see people being delighted with GridGain Professional and GridGain Enterprise, is that it will create a platform, a horizontal platform within your organization in the enterprise to use all your in-memory needs. So people will bring this in to solve a certain use case. And then as they see all the different functionality that GridGain Professional offers, they will create sort of a centralized version of it that all the applications can use. So one place, one single system in order to manage all your in-memory application needs, streaming, microservices, OLAP, OLTP, caching, etc. GridGain Enterprise has some plugins that make it more enterprise ready. So it makes GridGain Professional more enterprise ready. That includes some security features, including authentication, authorization, and auditing, a monitoring tool and ease of management, and some high availability features. And that is where we're going to drill down in today, is to look at one of the high availability features that GridGain Enterprise offers, which is our multi-data center replication. We also offer network segmentation, remediation and identification, and rolling upgrades. But probably the superstar of the enterprise feature set is multi-data center replication. So that is the quick version of Apache Ignite, GridGain Professional, and GridGain Enterprise. So why do you need multi-data center replication? And in this day and age, as the title of the webinar suggests, if you're slow, you're down, and if you're down, you're dead. There are most applications that you are using in a B2C environment, or even in a B2B environment, have so much competition and so much, they're so mission critical to so many people that if they're down because a data center goes down, or they're no longer going to be used, and you can jump to a competitor's website. I had the opportunity to work with Netflix a few years ago, and they are so dedicated to making sure that there is never any downtime that they've implemented a system called the Chaos Monkeys that will go through the system and simulate data center outages, boxes going down, network segmentations, and every application that somebody builds at Netflix has to be able to withstand that type of outage. And I think this is a best practice that anybody who creates an application should be looking at. And why? Because stuff happens. There's failures. Data centers go down. You may think of climate change as a reason for this. I built these slides a few weeks ago, and unfortunately the news has backed up some of these things. Tornadoes and hurricanes and earthquakes. Those are all real problems that physically can affect your data center. There's flooding, there's tornadoes. And even if you think that climate change is a hoax or you don't believe in it, there's always bring your kid to work day. I have small children. I always try to hide the scissors from them. They can never find their shoes, but they always find those scissors. So you might have toddlers running through your data center, cutting up network cables. Or you have no idea who your data center hires to take care of your systems. So you don't have, once you have something in a co-located system, you do not have a lot of control over the weather, over who they hire, or just plain old outages. Some of these are a little tongue-in-cheek, but this one actually happened to me. I had a colo out in Virginia, and it went dark, and the reason why was a truck had backed up into the power supply. At that point, multi-data center replication became a very important feature on the top of my head. Like, can't just rely on a single one. And if you take a look at this map from the National Oceanographic and Atmospheric Association, they're saying where the high, medium, and low for earthquakes, tornadoes, and hurricanes are. According to this map, there isn't a lot of safe places. So it behooves you to set up your system to replicate to multiple different data centers. But some people ask me, well, what about the cloud? Is the cloud a good option? And definitely, you can definitely replicate and do multi-data center replication to the cloud and on-premise, or to two different clouds. And what's nice about the cloud is these problems still exist, but they're no longer your problem. You got to pay somebody else for it to be their problem. So either direction that you go, on-premise or in the cloud or in a hybrid way, will work with GridGain Enterprise. So let's go into a little bit about the actual technology here. So when you're working with multiple data centers, it is often important to make sure that when one data center goes down, another data center is fully capable of picking up its load and data. Data center replication is meant to solve exactly this problem. When data center replication is turned on, the GridGain Enterprise in-memory database will automatically make sure that each data center is consistently backing up its data to other data centers, or there could be more than one, and it supports both active-active and active-passive modes for replication. This allows data transfer between caches and distinct topologies, possibly located in different geographic locations. When a cache update occurs in one topology, it can be transparently transferred to another. Each distinct topology is capable of sending or receiving cache updates is called a data center. Some of the features that are available in the data center replication is batching. So updates in a sender cache are not sent to the sender hub immediately, and we'll talk about what those sender caches and sender hubs are in a bit. And they're accumulated in batches, and once the batch is too big or too old, it is sent off to be replicated. You can also provide an optional filter for cache updates. And so updates that don't pass that filter will not be replicated. So you have some flexibility there about what ends up getting replicated. This can be used for compliance between different countries. So if you're in the European Union, you know that certain data can't move from one country to another. So you could use filtering there to make sure only the appropriate data gets replicated out to a different data center. Failover, and in case a sender cache sends a replication batch to a sender hub, and the sender hub goes down before acknowledging it, that sender cache can automatically resend the batch to another sender hub. So it makes sense to set up more than one sender hub or receiver hubs in your topology. It can support complex topologies, up to 31 different data centers participating in disaster recovery. And you can have data center A replicating updates to several other data centers. You can have data center A replicating to data center B, and then center B forwarding these updates to data center C. You can have data centers A, B, and C replicating data to each other. And to avoid loops in these complex topology, you can filter some updates on the sender hubs. Replication for a particular sender cache can be paused either manually or automatically. So if you do know that you have a data center down, you may want to have there be a pause in replication and then go ahead and resume it. And when that replication is paused, cache updates are not replicated to the remote data centers. And so once it's resumed, you can force sending the entire cache content to the remote data center, and that's called state transfer. There's also conflict resolution. So in active-active scenarios, when updates to the same cache occur in different data centers, we can update to the same key can be seen as a conflict. So this is considered a race condition, for example. And to ensure consistent conflict resolution, you can plug in your own implementation of a conflict resolver. And we'll talk a little bit about that in a little bit. But by default, it will be the most recent update will win. So let's talk a little bit about the different roles. So I've been talking about sender hubs and sender caches. Let's go ahead and define these. So first off, there's 4 roles. A sender cache is the cache on the data node in the data center where the original update happens. So in the screen here, this is in DC1, and the gray boxes are the sender cache. You also have a sender hub, and this is a node that receives the update from the sender cache. This can be any node in the cluster. It does not have to be a special one. You don't have to create a new one. You just can designate one or many different nodes as sender hubs. You then have a receiver hub, which is the node that receives the update in the remote data center and routes them to the receiver cache. And in this particular example, data center 2, the gray boxes are the receiver cache. So the receiver cache is the cache on the data node in the remote data center where the replication is set. It gets the update from the receiver hub and applies them. So the only restrictions here is that the sender and receiver hubs need to be, so this receiver hub and the receiver cache need to be in the same data center, and the sender hub and the sender cache need to be in the same data center. But any node, as I mentioned earlier, can be a sender, receiver, cache, or hub. So how this works, the sender cache, so all updates to the sender cache are passed through a filter. That's called the entry filter down here. And you can just choose to define a filter or leave no filter. But all items that pass a filter are accumulated in batches on the primary data nodes. When the batch hits the capacity or time limit, depending how you set it up, it will be sent to the sender hub. And the sender hub that sends it is selected using a load balancing policy. So if you have more than one sender hub, it will pick based on a load balancing policy. Once the sender hub sends an acknowledgement that it received the batch is removed from the sender cache. It is if the acknowledgement reports an error or never arrives, the sender cache sends the batch to another hub. If all the sender hubs fail, replication is paused and the batch is discarded. So that's very important to keep in mind. So if you do have number of nodes out, it will discard the batch and will not do the replication. So the sender hub then receives the batches from the cache and relays them to the remote data center's receiver hubs. You define the caches for the sender hub to work in the configuration on your GridGain enterprise node. The sender hub stores batches received from sender caches in memory or on disk, and you decide where. And once the batch is saved, an acknowledgement is sent to the sender cache. A similar process occurs when the sender hub takes batches from its store and sends them to the receiver hub. The receiver hub acknowledges receipt of the batches after it's stored them on the appropriate location in the destination cache, after which the sender hub can remove the batches from the store. The sender hubs communicate with the remote data centers by sending handshake requests to the receiver hubs in that data center. The addresses of these hubs are provided in the properties file we'll take a look at in a little bit. And the receiver hub then acknowledges the handshake with success after checking for virgin matches, etc. To maintain the connection, the sender hub sends ping requests to the receiver hubs, and connections are considered broken after a configurable length of time. So the receiver hub receives the batches from the sender hub, stores them, and acknowledges the receipt, allowing the sender hub to remove the batches from its store. The receiver hub starts a TCP server that allows the sender hubs to connect and send pings to confirm availability. The receiver hub applies the batch to the correct receiver's cache in the local data center, and after the batch is successfully applied, the receiver hub sends an acknowledgement to the sender hub. So the receiver cache is just the cache in the data center where the data is finally landed. And before the data is inserted, GridGain Enterprise allows for user-defined conflict detection to check that the update doesn't conflict with the existing cache value. If there is a conflict, your conflict resolver will be invoked, which can also be that you also actually defined. So there's 3 different options for conflict resolution. You can use new, which is overwrite the existing entry with the update value. Use the old one, throw out the new update value in favor of an existing value, or merge, and that will provide a value for the entry to merge manually. By default, it's to use new, but you can set that up in the configuration. So we're going to take a look now at the actual code that you would use to set it up. But before we get there, one thing I do want to point out is, Albert Einstein was right. The speed of light, it's a constant, and it's the fastest thing you can do, and it's not just a good idea, it's a law. I do get a lot of people asking me, hey, I have a data center in Tokyo and I have a data center in San Francisco, and I have a sub-millisecond SLA latency. And it's kind of like, I can't really help you there. That's physics. Once our engineering team has figured out how to improve latency between different data centers, I'll let you know. But for now, we are limited by the speed of light. So keep that in mind when you're setting up your SLAs and your consistency, consistency and availability guarantees within your application, keeping in mind where your different data centers are located. So it's fairly straightforward to set up the multi-data center replication within GridGain Enterprise. First thing you're going to need to do is set a data center ID. Again, this could be from 0 to 31, so 32 different data centers available. And you would configure a sender cache using the cache DR sender configuration. Make sure you set the batch size. So these are the configuration here. Next, you want to make sure you configure your sender hub. So you're going to use the DR sender hub configuration. And here you want to make sure that the cache, that what will happen is the cache will be updated, that there's any replication filtering is applied, that the update is added to the local batch, and once the batch is full, the batch is sent to the sender hub. You also need to configure a receiver hub. So here, the receiver hub will receive the batch from the sender hub. It will send acknowledgement of the batch to the sender hub, and then relays the batch to the receiver cache. You can also set up replication filtering. So this will define any custom logic to determine which cache data to replicate. And you use the cache DR entry filter in order to determine the validity of the update. Last but not least, for conflict resolution, you use the cache conflict resolver, and you can implement any type of conflict resolution that you want there. And again, the default is going to be use new. So the last question is, when should you do this? When should you be setting up or considering using multi-data center replication in your application? And a lot of people are like, well, I'm just going to try it first and then see how it goes and then expand to multi-data centers. That's perfectly valid, but definitely best practices is to think about it now. So keep in mind when you're developing your application if you're going to be using multiple data centers, and that way you can set expectations appropriately for SLAs or determine which data centers are most appropriate for you based on distance, latencies, etc. So it's a good thing to keep in mind even when you are just beginning a project, even though this does tend to happen later on in an application development process. So what did we go through? First, we went through what is Apache Ignite and GridGain, GridGain Professional and GridGain Enterprise. Talked about who needs multi-data center replication. Pretty much anybody who has an application where slow is down or down is dead. Why is using multi-data center replication essential to my modern data-intensive application? Well, there's just too much out there, too much uncertainty, too many things that we don't have control over around the different data centers. that having backups in different places, mitigate that that issue. Where can we deploy it? We can deploy it in the cloud. We can deploy it on premise. We can do a hybrid of both. How does it work? We went through a lot of different scenarios talking about how we have sender caches giving information to the sender hub. That goes through a filtering process. If necessary, that gets replicated out to the receiver hub. The receiver hub then does any type of conflict resolution before it applies to the receiver cache. Fairly straightforward, very simple to enable in your application. When should you do it? You should do it now. Start from the beginning. Design your application with multi-data center built in. So that is what I have to say. I think we have about 10 minutes left for questions at this point, and I'm going to hand it back over to Terry to take a look at what questions we have.
All right, thank you, Rachel. If anyone has questions, please enter them in the questions tab in the Go to Webinar control panel, and we'll answer what any questions that you might have about today's presentation. Okay, so I don't see any questions right now. So Rachel, thank you for today's presentation. If you would like to reach out to us after the presentation or after the webinar and ask any questions, please feel free to do so. We will send out a link to today's webinar recording as well as the presentation slides later today. Thank you for attending today's session. Goodbye, everyone.